Hello, thank you for coming to talk accelerating skill acquisition of two-handed drumming using pneumatic artificial muscles. I'm Takashi Goto from Hamburg University of Applied Sciences. This work has been collaborated with Swagata and Yuichi Kurita from Hiroshima University, Katrin from Buse University of Applied Sciences, Pedro Lopes from University of Chicago, and Kunze from Keio University. In this paper, we are looking at skill acquisition using wearable force feedback device made by artificial muscles. Learning a new physical skill is a demanding task even for individuals who have high dexterity. Learning drumming is also very hard because it often requires asymmetric hand coordination between both hands, while involving the multi-sensory conditions such as visual or auditory informations. Proprioceptive feedback helps in this situation, and body actuation technology guides users to consolidate their motor skill with less required time and less effort. Previously grounded haptic devices or a large exoskeleton were used for these purposes. On the other hand, wearable force feedback devices are really promising for the field of motor learning since they are lightweight and interfere less with the user's own movement. However, these devices have not shown to actually improve motor learning yet. Thus, we try to demonstrate that soft exoskeleton using push muscles improve motor learning by conducting user study. To demonstrate this, we use pneumatic gel muscle, a type of pneumatic artificial muscle driven by very low air pressure, while maintaining enough force to actuate the user's body. Pneumatic gel muscle, shortly pump, is lightweight and is capable to provide strong force. However, it often requires a large compressor. In user study, we also use a compressor because of air capacity, but still the actuator works with a small CO2 gas cylinder, and that allows us to use the devices as wearable form factors. To design drumming motion, we use only two pneumatic gel muscles on one hand, total 4 for both hands to rotate wrist to drum. User's wrist was spinate first and next pronate to hit drum with a drumstick. In the user study, we compare our setup against audio feedback in where people hear left or right as a timing to drum. They try with proprioceptive or audio feedback first while looking at scores. After this, they drum without any feedback and scores. Thus, the tasks were typical try and record design, and they were given only best tempo in record sessions. Participants required to try 10 times for each task, therefore they need to 30 times for each condition. We recruited 12 participants who had never trained for any musical instrument, and prepared 3 levels of tasks. These are tasks designed for our user study. All tasks were performed at 80 beats per minute, and the task in each level consists of 2 similar drumming patterns, and we used one task for our setup or auditory condition, and another one in same level was used for another condition. We randomized the order of tasks, and the order of condition was counterbalanced. To evaluate result, we estimate how correctly they could drum from the perspective of error rate and timing error. Error rate is how many they make mistake in each task, and the mistake was counted if they missed some timing to drum or drum with wrong hand. The duration of the timing is plus minus 62.5 milliseconds, and that's decided based on the time length of smallest node in all tasks. For timing error, we estimate the error from the distillations. Thus, maximum and minimum value of the timing error is plus minus 62.5 milliseconds. For the result, we performed two tests for the datasets that's correct in our user study. The parametric test was performed after square root transformation of the dataset, both error rate and timing error. We found that the result of error rate is statistically significant, and the result confirmed that the participant could more correctly recall of drumming pattern with our setup against auditory condition. However, we couldn't find any significant difference for timing errors. We also correct participants' comments after each condition. 9 of 12 participants stated that they prefer the setup over the auditory condition, and 11 of 12 participants stated that they felt an improvement after PGM condition, while 7 participants stated a perceived improvement after the audio condition. We also got many positive comments. Often they stated that the experience is fun and less pressure. And some participants gave a comment suggesting PGM condition might be less sacrificing their agency. It was out of the scope at the moment, so. To summarize our presentation, we validated the skill acquisition by conducting user study that was focused on drumming training. And our exoskeleton using pneumatic artificial muscles confirmed that the setup improves the correct recall of drumming pattern compared with auditory training. Still, there are a couple of open questions. First, our experiment took only 90 minutes, and it's quite short to estimate learning motor skills, because often consolidating motor skills require much repetition over a longer time period. Second, the results of the study confirmed that improvement of the participants' pattern recall. However, the effect sizes were not much large. We are really excited about this research, and many participants also had a good impression of our exoskeleton setup. As an open question, we are still questionable what happens if we implement motor learning with our setup in a more complex situation that involves more complex motion design or more complex multi-sensory coordinations. Thank you so much for listening, and I really appreciate your question for further discussions.